Good morning, everyone. Today's class is the lecture 2 of the chapter Alternating Current. Let us quickly revise what we did last class. So I told you any alternating quantity mathematically can be represented by, if y is the symbol for the alternating quantity, then it can be written as, if it is alternating, we can write A sine omega t. We can also write cos omega t. Now, this A was called the maximum value of y, which is called peak value,
Amplitude.
or we can say amplitude. And who remembers what is this angle called?
Phase.
Phase.
Since like vectors used to have magnitude and direction, and we used to represent vectors by an arrow. Similarly, alternating quantities, as we can see in this formula, they have amplitude and phase. Phase is angle. So this kind of alternating quantities can be represented by an arrow such that the length of the arrow will give you the amplitude, and the angle made by the arrow with any line, this line you can choose yourself. The angle made by this arrow with any line will give you the phase. This arrow is what is called in physics phasor. The reason why we do this will be very clear as we study this chapter, because later we will have to add two or three alternating quantities. Now, if you are very good in trigonometry, we can do it with trigonometry, but it takes time. So, if you can remember this concept of phasor, where the length of the arrow gives you amplitude and angle gives you phase. If you remember this, then it is very easy to add alternating quantities using the concept of phasors. And you will see it soon, okay? Alternating current, how we wrote? I naught sine omega t, where I naught is the peak value, and omega was called, if you remember, angular frequency. And the formula for it is 2 pi by time period, or I can write 2 pi into frequency. Similarly, voltage can be written V naught sine omega t. And then we found that AC values, whenever we measure AC values through instruments. So when they say AC voltage of 220 volt is applied, it is through measurement. And whenever a device measures AC, it always measures the, what value I told that day?
Root mean square.
RMS value. And the formula for this RMS value, if you remember, was I naught by root 2. Then, if you remember, after this, what did we do? We connected AC to a resistor. Yes or no?
Yes, sir.
Yes, sir.
So this is your AC source. This is the symbol for an AC source, and the applied voltage, since it is AC, we write as V naught sine omega t. Equation 1. Then quickly we try to find the current. Now, if I show the current this way, it means right now this is plus, this is minus. But remember, this is AC, so later it will change. This will become plus, this will become minus. So that time current will flow this way. So there's no point showing the current, okay? Now, since this is resistor, we can use Ohm's law. So to find the current, I can just use V by R. V equals to IR, Ohm's law. So I equals to V by R. Substitute this V. Then you can write this as I naught sine omega t. Equation 2. Look carefully. What is the phase of voltage? Omega t. What is the phase of current? Omega t. And both are sine function. Therefore, what does it mean? In a resistive circuit, current and voltage have what phase, I should say? Same phase or different phase?
Same phase.
Same phase. Very important. In a resistive circuit, both voltage and current have same phase. So if this is the voltage phasor, current phasor also should be in the same direction because this angle should be same for both of them. By the way, you don't have to show at an angle, you can show this way also. Why, sir? Because students, you all know that this time keeps on changing. Hello, the only thing that keeps changing is time, no?
Yes, sir.
So as time keeps on changing, this arrow will, you can see, rotate. So that's why some people say phasors are nothing but rotating vectors. Rotating vectors. So with time, this angle will keep changing. So when the phasor is here, that time you can take photo and you can show. So you cannot tell only this is right, this is also right. Understood? But you have to show both the alternating quantity, current and voltage, in the same phase. Also, in place of whom I wrote I naught, V naught by R. So I wrote I naught in place of V naught by R. So if resistance of the circuit is more, the peak value of the current will be less. That's why we say R is resistance. It opposes current. After that, what we did, we connected AC to capacitor. AC to capacitor. Then now in capacitor, remember, we can calculate charge, CV. That is the formula for capacitor. You cannot use Ohm's law. And voltage is V naught sine omega t, because it is alternating voltage. By the way, students, if they ask you what is the phase difference or what is the phase relationship between applied voltage and charge, what will you say? Yes,
Same phase.
same phase. Because sine omega t, sine omega t. Is it clear?
Yes, sir.
In capacitor, charge and voltage are in same phase. But remember, we are not interested in charge actually. We want to know current. Remember, it is instantaneous voltage, it is changing with time. So I want instantaneous current. How to find instantaneous current? dq by dt. Take differentiation of this. See, V naught will come outside. Differentiation of sine omega t is omega cos omega t. Then in place of this, you can write I naught. Cos omega t can be written as sine omega t plus 90. I know we can write 90 plus omega t also, but write omega t plus 90. Now look carefully. See the voltage formula and current formula. What do you see? Phase of voltage is omega t with sine. This is omega t plus 90. So who has more phase? Current or voltage?
Current, sir.
Current.
So if this is your reference line, and if your voltage has phase omega t, V naught, your I naught will have phase omega t plus 90, like this. Okay, either you can show this way, or you know these guys will keep rotating this way, like this, anti-clockwise.
Yes, sir.
Also write V naught, I naught. So please remember this, students, that in capacitor, current leads, L-E-A-D-S. Current leads in race, no. Current leads in phase. By how much angle? 90 degree. Why I'm saying leads? Because there is a plus sign. Okay. Today, what we are going to do is we are going to replace this capacitor by something called inductor. Carmel students, yesterday something called inductance I told. Any memory is there?
Yes, sir.
Okay. So little bit revision we will do for AAC also, Carmel also. What is this inductor? Fast we will revise once. Okay, 5 minutes. So these are the three circuit elements. There are three circuit elements which is important for you: resistance, capacitance, inductance. Resistance opposes current. Capacitance is usually used to store charge. Inductance, what it does, let us quickly revise. Okay, students, now you see, if you take some coil and you connect a galvanometer, Faraday found that whenever you move a magnet into or out, there was deflection in the circuit. So this was a discovery made by Faraday. Now, when you move the magnet, the lines of magnetic field cutting this surface will change or will not change. If you bring it nearer, more lines will pass. Don't you think so?
Yes, sir.
Because magnetic field lines looks like this. Like this. So if your circuit is far, here let's say 3 lines are passing. But if the same circuit is near, more lines are passing. Agree or not?
Yes, sir.
So when you move the magnet, the flux, why I said flux? Because lines are cutting the surface. But which flux? Magnetic flux changes. And how to write rate of change of magnetic flux? d phi by dt. So this rate of change of magnetic flux is responsible to induce current in the circuit. But if there is current, it must be because of some EMF. Because how do we write current? EMF divided by resistance. Yes or no, students? So if current is there in this circuit, it means some work is done per unit charge all around the circuit, and that is definition of EMF. So Faraday discovered whenever magnetic flux changes through some circuit, through some coil, an EMF is induced in the coil. So this is a new law which is called Faraday's law. Then Lenz discovered, who discovered Lenz, that whenever you bring the north nearer, this side of the coil will act like what pole? AEC students?
North
Pole.
So that when you bring, whoever is bringing the magnet this side will experience repulsion from this north. And you have to do work against that repulsion. Then only you can explain why there is electricity here. If there is electricity here, there must be some energy formation, I square RT. And if energy is there, somebody has to lose energy, somebody has to do work. And that somebody who is that is the person who is pushing this magnet. And why he has to push? Because when you bring north this side, this face will act like north pole, so there will be repulsion. So therefore you have to apply some external force, and it is the work done by you that results in the energy produced in this circuit as current. Therefore, students, whenever you create a change in flux, the current which is induced here, the EMF which is induced here, will always oppose the change, in magnetic flux. To show that opposition, we put a minus. That's it. Then finally, how do you bring the concept of inductance in the story? How do I bring inductance? Simple. Take this solenoid. Pass current I. Past any Carmel students. Tell me formula for magnetic field inside the solenoid.
Mu naught Ni, sir.
Mu naught Ni. And this small n is not number of turns per unit length. Now observe something. If current increases, this magnetic field increases. Therefore, magnetic flux, which is B into A, right? Just like electric flux is E into A. Okay, let me write cos theta. So when current increases, magnetic field increases. When magnetic field increases, magnetic flux increases. That means magnetic flux can be told proportional to the current in the same coil. And if I write equal to, a constant will come. That constant is what is called inductance. If I substitute this here, what will I get? E equals to minus. If you substitute this Li here, L is constant, I can take L outside. So I will get this formula. So please memorize these, students. Do you all remember this formula?
Yes, sir.
Which law is this?
Newton's second law.
Newton's second law.
Okay. Can I write like this? Can I write like this?
Yes.
Sir.
Now, observe the role of mass. If a force is applied to change velocity, same force you apply to change the velocity by same amount. So keep same force same and change in velocity also you want same. Meaning, let us say you want the body to move from 0 to 2 meters per second. Now, if the body has more mass, what does it mean? It will take.
More time.
More time.
That's the meaning of mass. So mass opposes your change in velocity. Does it mean mass will not allow your velocity to change? No, no. If you apply force, your velocity will change. But mass will try to oppose that by stretching the time taken. So the more mass you have, the more time you will take to change the velocity. Imagine your mass is almost 1000 crore kg. Then a very small force will take what time? Huge time it will take. It may take years to move from here to here. And if it is taking so much time, then you will feel like the body is at rest only. Yes or no, students? If I move this marker from here to here in 1000 years, from here to here, then for 10 seconds, you will not see the marker moving also.
Yes, sir.
Yes, sir.
Similarly, can I write this formula like this? Now observe carefully here. Similar to this equation you see now. If your inductance of the circuit is more, what does it mean? Your current will change, no doubt. But what does it mean? It will take.
More time.
More time.
So that is the meaning of inductance. Inductance basically opposes change in current. Okay. Just like mass opposes change in velocity. Write the topic AC through inductor. Inductor matlab the device which has inductance, and any coil has inductance. Even a single loop will have inductance, remember. So let us say this is your inductor whose inductance is L, and I am going to connect a AC. So what is the formula for applied AC voltage? V equals to V naught sine omega t. Be careful. This is not resistor, so you cannot use Ohm's law. This is not capacitor, so you cannot write Q equal to CV. Okay? Then what to do? Whatever voltage you apply, it is alternating voltage. Don't write, listen. It is alternating voltage. Therefore, the current here will be alternating. And whenever current changes, what I told, this inductor will induce EMF to oppose the change in current because of its inductance. Yes or no?
Yes, sir.
So the EMF induced in the inductor what it will be? Small e equal to minus L di by dt. Okay. So what will be the net voltage? Net voltage in the circuit or net EMF, let me write. Or net voltage. Net voltage will be this applied voltage plus this EMF. Yes or no? Because this is also voltage only. This is also like battery here. But that battery will oppose this battery, remember. They are all like battery only. Only thing is the voltage keeps on changing. That's it. So quickly tell me, the total voltage can be written voltage of this plus voltage of this. Now, if there was resistance, how do we write total voltage? I into R. Yes or no?
Yes, sir.
But in this circuit, do we have resistance?
No, sir.
No.
We are considering only inductive circuit right now. Later we will put resistance also. So because there is no resistance in the circuit, this should be 0. That means if you substitute this voltage here, you will get V naught sine omega t, and this EMF here, you will get minus L di by dt equal to 0. Then you take this one this side, then minus will become plus L di by dt equals to V naught sine omega t. Remember, I told you in all the 3 cases, our aim is to find current. In resistance, it was easy. Ohm's law. V equal to I into R. So I is equal to V by R. Algebra. Only algebra. In capacitor, little work we did because we did not get current directly. We got charge. And from charge to go to current, what did we do?
Integration.
Differentiation. Differentiation, dq by dt, right?
Yes, sir. Yeah. Yes, sir. Yeah.
Now see, current is here. So how to remove somebody who is under the jail of square root? Square it.
Carrying on.
Yes, sir.
And how to remove somebody who is under the jail of differentiation?
Integral.
Integration.
So we will do the next step. First you write till here. But let me just one more time, last I'll explain. First understand one thing, students. Every circuit has something called inertia, which opposes change in current. Now we did not consider those inertia in the previous chapters, but now we want to do that. So that property of a circuit which opposes change in current is called inductance. And the formula for inductance is whatever EMF is induced here, that is equals to minus L di by dt. The minus sign simply says that the EMF opposes the external agent who is trying to change the current. So opposes change in current. So the net EMF is applied EMF or applied voltage plus the voltage induced in the inductor. So this is the total voltage, and that should be equal to IR. But there is no resistance, so 0. Then substitute, take it this side. Now we are ready to simplify. But first you write. So let us separate the variables. Who are the variables here? Fast you tell. 2 variables are there.
INT.
Which changes, by the way.
INT.
Current and
Time.
time. So let's separate the variables. So here I'll keep di. Others I will take that side. V naught, L you come down, sine omega t, then dt. After separating the variable, I will integrate both sides. Integrating both sides, integral di, V naught by L, integral sine omega t dt. Okay, what is integral di? I only, right?
I.
Plus, sorry, not plus, equal to V naught by L. Integral of sine omega t is what? Minus cos omega t by omega or into omega?
By
By omega.
Differentiation is into omega. So in integration by omega, which I can now write V naught by L omega minus cos omega t. Now remember, your voltage which was applied was V naught sin omega t. Call this equation 1. The first one which you wrote, there you write equation 1.
Yes, sir.
Now we are there. We almost got current. But the problem is this is cos. I want to convert this into sine. Now be careful, there is a minus sign. Okay, so look here, everybody. Everybody tell me sine 90 minus theta is what?
Cos theta.
Cos theta.
But I told you, this way we don't want to write. We want to write theta minus 90. Because that will help us to understand whether the phase is more or phase is less than voltage. In case of capacitor, how we wrote omega t plus 90 we wrote. So that way I want to write. So let me do ulta. If I do ulta, minus sign will come and sign of minus theta is minus sin theta. Tell me, understood this guys, all of you?
Yes, sir.
So when you ulta this, if you reverse the places of these two, minus sign has to come because it's sign function. Be careful. So I can write sine theta minus 90 as minus cos theta. So therefore, in place of minus cos omega t, what I can write? I is equals to, first of all, what I can do? This one shall I write I naught? It will look nice, no?
Yes, sir.
And this fellow minus cos theta, I can write what I told, sine omega t minus 90. Tell me, clear or not clear?
Yes, sir.
So be careful that you have to do this way, then only equations will come properly. So equation 2. Now look 1 and 2. What is the phase of voltage? Omega t with sine. What is the phase of current? Omega t minus 90 or plus 90 this time?
Minus 90.
Minus 90. That means what? That means current is leading or current is lagging?
Lagging.
Behind. In race, no, in phase.
Phase.
So from 1 and 2, we see that in inductive circuit, not resistive, not capacitive. In inductive circuit, which has inductor only, we see that in inductive circuit, current lags behind voltage in phase by 90 degree. Then they will ask you to draw phasor diagram. Phasor diagram I will show you here. The phasor diagram. This is last, you have to write this one. So how will you write phasor diagram? If this is the phasor representing voltage, this time what is the phase difference? 90 degree only. But this time current is ahead or behind? Ahead matlab this side, remember.
Behind.
Show current. Yeah. So this is the phasor diagram. This also you have to draw, remember, not only the derivation. Finished. Of course, here you have to mention one small thing. Where in place of whom you wrote I naught.
V naught by L omega.
V naught by L omega. So that also you mentioned. Okay, so write down. Now, everybody see your notes. Like this formula, I created for capacitor also. Tell me how it was. I naught is equals to V naught by, who was here?
1 by CV not CV C omega.
C,
Omega.
because if you see the derivation, C omega came in the numerator. Today also I showed derivation. C omega was in the numerator. So how to write it in the denominator? You write it as 1 by C omega, because C omega can be written as 1 by C omega. So why I did that way? So that we will come to know who is playing the role of resistance. So here this is playing the role of resistance. Here who is playing the role of resistance?
L omega.
L omega, because it is in the denominator of I naught in the formula. Okay, so let us put all of them together in a nice box. So in resistor, current phasor and voltage phasor are in same phase. And I naught, if you see the derivation, was V naught by R, or I can write V naught is equals to I naught R. In capacitor, we found current leads here. So here was your voltage, here was your current. And I naught was V naught divided by 1 by C omega. So what we did, if you remember, we gave this quantity a name XC, and we called it capacitive reactance. Do you remember?
Yes, sir.
And this capacitive reactance, basically what it does, it opposes AC. It opposes the flow of alternating current. And we wrote this formula as V naught by XC. If you cross multiply, you can write in the same style. V naught is equals to I naught XC. But please understand, students, this is voltage across resistor. This is voltage across
Capacitor.
capacitor. The third one, today we learned in inductor, your current will lag. It will be behind voltage by 90 degree, and I naught equals to V naught by, what did we find today? L omega. It was not 1 by L omega, remember, it was only L omega. So why don't we give this a name? This name is XL. And if this is called capacitive reactance, this XL is called inductive reactance. I will give the definition, don't worry. Inductive reactance. And we can write this in a simple way, XC. XL. Or if you cross multiply V naught, how will you write? I naught XL. In other words, students, you can apply Ohm's law for capacitor and inductor also, provided you don't write R, but you write XC. Understood?
Yes, sir.
Whatever formula we have for Ohm's law, we can write similar formula. That is the reason why we are creating all these things, so that it is easy for us to remember. So in capacitor, XC will play the role of resistance. In inductor, XL will play the role of resistance. But one thing we need to remember, XC formula is 1 by C omega. And XL formula is L omega. Okay. So bottom line, don't forget, XC 1 by C omega, XL L omega. And from the units, you can see volt by current, volt by ampere. Here also volt by ampere. Here also volt by ampere. So clearly these two should be ohm. Yes or no, students? XL and C should be same unit as R, because this is voltage by current. Voltage by current. Here also voltage by current. So unit wise, it is ohm. So let me just give you the definition of inductive reactance, and few things let me tell you, just like I did for capacitive reactance. Let me give you the definition of inductive reactance, XL. So write down, it is the opposition, because it is playing the same role as resistance, remember. So it is the opposition to the flow of AC by an inductor. That's it. Its formula is L omega. In terms of frequency, 2 pi f. So if I plot graph of XL versus frequency, which I did for capacitive reactance also, it was rectangular hyperbola, because it was 1 by frequency. It was inversely proportional to frequency in case of capacitor. Check the graph. Because it is, XC was what formula? Now also I told you 1 by C omega. So 1 by C into 2 pi f. So frequency is in denominator. So with increase in frequency, capacitive reactance decreases. So the graph was like this. But here, what kind of graph will you expect?
Linear.
Linear, because it is proportional, directly proportional. So here let me write, therefore XL is proportional to frequency. So the graph will look linear, passing through origin. And for DC, what is frequency that Akshay also told?
0.
No change in current. So frequency is 0. If frequency is 0, XL is also 0. So inductor offers no resistance, no opposition to DC. Because, and it makes sense also. It makes sense also. What did I tell you in the beginning? Inductance matlab like mass. It opposes change in current. But if the current is DC, it will not change.
Yes, sir.
Therefore, it will not oppose. So if you are at rest, you will remain at rest. No need to oppose. Only when you want to move me from rest, if you want to move me, then I will oppose. Then my mass will oppose. So for DC, inductor offers no resistance. So for DC, inductor offers no opposition. It is like Congress, no opposition. Like this part I should delete now. So now we are going to start the first 5-mark question. All these derivations are 3 marks. So it is called series LCR AC circuit. Matlab, not resistor, not capacitor, not inductor, all the 3. But in series. For parallel, we'll study only for JEE students later. So all the 3 elements in series with AC source, not battery, okay, AC source. And we will see what happens. But before that, you need to revise those 3 things. In resistor, what happens? In inductor, what happens? In capacitor, what happens? And how we write voltage for each one of them. In resistor, I naught R. In capacitor, I naught XC. And in inductor, I naught
XL.
XL. But remember, XC and XL depends on frequency. Resistance has no frequency. Resistance is rho L by A. Rho
Yes,
L
sir.
by A has no frequency, but XC and XL depends on frequency of the source. So, what is the main derivation here? Same thing, we will apply voltage and we'll try to find the formula for current. Same thing like we did in the 3 cases. And then we will try to also find the net opposition to the flow of current, net opposition. Like in case of resistor, it was R. In case of capacitor, XC. So in this circuit, when all of them are there, what will be the net opposition? Some of you may think. Some of you may think this one because it is series. So you may think you add all the opposition, right? So we have to check whether maybe this is right, maybe this is not right. And also we have to find phase difference. What phase difference? In case of resistor, current and voltage were in same phase. So if they have same phase, what will be phase difference?
0.
0. In capacitor, current was leading by 90 degree. In inductor, current was lagging by 90 degree. Now what will happen? Will it be still 90 degree? Will it be maybe 40 degree, 30 degree, 60 degree? So that all that we have to derive formula. Okay. So let's start. So series LCR AC circuit. So first we'll write, let us consider an AC source with voltage V equal to V naught sin omega t in series with, let us consider an AC source with voltage V equal to V naught sin omega t be connected with inductor, capacitor and resistor in series. Okay. So V naught is the amplitude of the applied voltage. What is V naught, students? Amplitude of applied
voltage.
Applied voltage. And every applied alternating voltage should have frequency. So omega is angular frequency of the applied AC source. So first let's draw a diagram. So inductor, capacitor, resistor in series with AC source. Inductor has inductance, capacitor has capacitance, resistor has resistance. Applied voltage peak value is V naught. So here the peak voltage, here and here, look carefully, don't write now. I'm giving you time to write or not. So the applied peak voltage between its terminals, matlab here, or I can say here also, is V naught. Okay, or I can write V equal to V naught sin omega t right now. Okay, now in series, what will be same, do you think? Current or voltage?
Current, sir.
Current.
Current.
So current will be same in the circuit, no doubt. So therefore, we will consider current as our reference. Why, sir? Because it is same in each one of them. Okay. So while drawing the phasor diagram, I will consider current as reference because current is same in all of them. Now, in resistor, current, and this you have to write, okay, even if you have written before, in this derivation you have to write. In resistor, current and voltage are in same phase. And what will be the voltage here? V naught R. Okay, peak voltage. With peak voltage, V naught R is equals to I naught into R. Can you tell why I did not write I naught R like that?
Current is same.
Because it is same in each one of them. So no need to distinguish current here from current here from current here. Yes or no?
Yes, sir.
In capacitor, current, we want to compare, we want to keep current as reference, no? Students, if I am ahead of you, then you are
Behind you.
behind me.
Lagging.
So In capacitor, actually the way we derived was like this. In capacitor, we told current leads voltage, which I can also say voltage lags behind current. Yes or no?
Yes.
So in capacitor, voltage lags behind current by 90 degree with formula was V naught here. If the voltage is V naught C, the peak voltage only, then how I can write I naught into C your notes? Who plays the role of R in capacitor?
1 by C
XC.
omega.
No, you give me the short symbol.
XC.
But remember, XC has a formula 1 by C omega, because XC is dependent on frequency. Number 3, in inductor, the way we derived was current lags behind voltage, which means voltage leads.
Leads current.
So voltage leads current in phase by 90 degree with V naught L. V naught L means peak voltage across inductor. What is the formula? If you see these three formula and tell me.
I naught XL.
I
I
naught,
not XL.
where XL should be L omega. Okay. Now what we will do, all these three we will put in a diagram. Okay, first you write. So now students, whatever three sentence I wrote, we will put in diagram called phasor diagram. So now I will draw phasor diagram corresponding to whatever we wrote. As I told, current is same in all the three elements. Here elements matlab circuit elements, resistor, capacitor, inductor. So I will keep the current phasor as reference. I know. Now quickly everybody should participate and tell. If this is your peak current for voltage across resistor, where it will be? Here only or somewhere else?
There only.
There only.
Here only. So this is your voltage across resistor. V naught R. Remember, this is phasor. So length of this arrow is this peak value, V naught R. Then in capacitor, current leads we derived. So here voltage lags. So voltage will be behind by 90 degree. This is voltage across capacitor. Understood or any doubt?
Understood, sir.
Because the diagram that we made was like this. Voltage of capacitor was here, current was here. But I told they are rotating vector, so they keep rotating. So one day when this current will come here, this voltage will come down, which basically means what? Current is leading voltage, or you can say voltage is lagging behind. Yes or no, students?
Yes, sir.
So it doesn't matter whether you show this way or this way. But here, because we want current to be reference, better to do this way. And in inductor, current lags, so voltage leads. Now there are two things we can do. We can make this voltage more than this, less than this, equal to this also, but equal we will not do. That is a special case which we will study later. But right now we'll assume this voltage is more than this voltage, so I will show a longer phasor. I will show you what phasor, students? Longer phasor. Please draw straight, okay? I'm not able to draw straight. I don't know what happened. So this arrow is my V naught L. So we want to now find the total applied peak voltage. Let me remind you the circuit. Here the voltage was V naught L. Be ready for some surprises. But don't worry, I will explain to you, so it will not be surprise. V naught C, and here V naught R. And here, how much voltage is the peak voltage applied? V naught. Remember or not? V equal to V naught sin omega t.
Yes, sir.
So now, if somebody will say, what is this V naught in terms of this tree? Many people may think like this. V naught is equals to V naught L plus V naught C plus V naught R. Yes or no? This is what we did in our DC circuits. In our DC circuits, whatever applied voltage was there, V naught V1 plus V2 plus V3. Yes or no, students? Pass you tell.
Yes, sir.
So this we did in DC circuit, but here we cannot. Why, sir? Because these voltages are alternating, remember. I mean, the voltage across each one of them alternates. So when one is going through positive cycle, the other may not be going through positive cycle. It may be going through negative cycle. You're understanding?
Yes,
Yes,
sir.
sir.
So you cannot always just add them. That's why phasor diagram comes to rescue. Phasor diagram will help you to add this tree easily. Let me tell you how now. Now tell me, the phase angle between this and this, how are these two directed? If these two were vectors, I would have told they are opposite.
Yes.
So if this is 10, this is 6. What is the total of these two?
4.
4. What direction? Up? Yes or no?
Yes, sir.
So first I will add this voltage and this voltage. Let me write first this voltage here. First I will add this voltage with this voltage. I will get maybe somewhere this much. So this is your, you can use same color, doesn't matter. This is your V naught L minus V naught C. Guys, idea you got how I got this? Like this one. This total, how I can write 10 minus 6. Clear or not clear?
Yes, sir.
Dear sir.
Now I have to add, because one more voltage is sitting here. So now I have to add this voltage with this voltage. What I will use? Parallelogram law.
Parallelogram.
So I will extend this dot 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 dot. So my resultant voltage will be here. And that resultant voltage is nothing but peak voltage of the applied voltage V naught. So let me call this O, A, B, C. So from phasor diagram, I hope everybody agrees if I write OB square is equals to OC square plus BC square. Pythagoras theorem. OB is length of this phasor, which is the resultant of the three voltages. And the resultant of the three voltages is nothing but the applied voltage, the peak voltage. So this is your V naught. OC is V naught R. BC is what, students? BC is same as AO, and AO is difference of this and this. V naught L minus V naught C whole square. Guys, understood or not till now?
Understood, sir.
Now use those three equations. In terms of current, V naught R was what? I naught into R. V naught L was
Yes,
what?
sir.
I naught into XL. V naught C was what? I naught
I
into
not into XC.
whole square. Then here you take square square, I naught square, R square. Here I naught common, then square it. What is left? XL minus XC whole square. Here and here I can take I naught square common. Something very nice is coming. It is like cooking, no, some nice curry on or painting. Some nice art will come now. Oi. But don't do mistake in the cooking, ma. Don't put too much salt. So I hope everybody understood. From this term and this term, I took I naught square common. Now I will take square root because I want V naught. Where will I write? First you write. So V naught will be square root of this. Square root of this will be what now? Square root of I naught square is I naught, and square root of this will be square root of R square plus XL minus XC whole square. So therefore, I naught will be what? V naught by root over R square plus XL minus XC whole square. Super. Remember, I told you our aim was to find current. In all the three cases, here we did some tricks and all, phasor diagram trick we used. Now student, notice one thing. If I ask you, who is playing the role of resistance here now? Here means when all of them are there. Let me remind you. When only resistor was there, peak current was peak voltage applied divided by R. Only capacitor was there, peak current was peak voltage by capacitive reactance. And when inductor was there, peak current was peak voltage by inductive reactance. So we told this opposes current. We already know this opposes current. This opposes current. Here, who is opposing current? This fellow or not?
Yes, sir.
And that fellow which opposes current when all of them are there. All of them matlab resistance and reactance. Resistance and reactance. That fellow is called impedance. So this we can write I naught is equals to V naught by Z, where Z is called impedance. Sorry, impedance. I'll give you the definition later, where what should be impedance in place of what I wrote Z? Root over R square plus XL
XL minus XC the whole square.
So in exam, they may ask you derive the formula for impedance, or they may ask you derive the formula for peak current, or they may ask you RMS current. RMS current is easy. Divide both numerator and denominator. Sorry, what numerator? Divide left hand side and right hand side by root 2. So I naught by root 2 will be IRMS. V naught by root 2 will be VRMS. Correct? No. So that I will show you later. But if they ask you to derive impedance of LCR AC circuit, this is the derivation. Also notice one thing, the angle between voltage and current, because remember this is the applied voltage. So the angle, the resultant voltage. So the resultant voltage and current are neither in same phase nor they are 90 degree. They are at some unknown angle. Yes or no?
Yes, sir.
That phase difference we need to find. Easy, tan phi we will use tan phi. First you write this. So now I will derive formula for phase difference phi between current I naught and voltage V naught. Remember applied voltage, okay? The resultant voltage. How to find this phase difference? Tan phi you use. So tan phi will be what?
Opposite by adjacent.
Opposite is what side here?
BC by OC.
Adjacent side is OC. BC is your V naught L minus V naught C. OC is your V naught R. Okay, then if you substitute, but first you write this much, I don't have space. So tan phi from here you come like this. Okay. So what will be your tan phi? V naught L minus V naught C by V naught R. Now what was V naught R? I naught into R, V naught L, I naught into XL, V naught C, I naught into XC. Take I naught common, I naught into R, I naught gets cancelled. So what is tan phi? XL minus XC divided by R. So these two derivation they may ask. Sometimes they will ask only this for 5 marks. Average power consumed. Average power consumed by LCR series AC circuit. We know that applied voltage, AC voltage, V is V naught sin omega t. Then current I will be I naught sin. Now tell me students, what do you think? Should it be omega t only, or omega t plus 90, or omega t minus 90, or it can be omega t minus any angle? Because it's LCR circuit, remember.
Omega t minus any angle.
Any angle. Or it could be plus also. So since I
Yes.
don't know right now, I will write omega t plus phi, I'll write. Okay, plus phi. So what I'm assuming, students, phi is the phase difference. Where phi is phase difference. Between whom? Obviously current and voltage. Total current and total voltage. So if these two are your instantaneous voltage and instantaneous current, then instantaneous current you can write because it is changing with time. Then what will be instantaneous power? What was the formula for power if you know current and voltage?
VI.
V equal to VI, or I can say I into V. W by T, work done by time, work done is charge into potential difference. Charge by time is current, finish. Substitute. So if I substitute these two, I will get I naught, P naught, correct? Sin omega t, one function, then sin omega t plus phi. Now students, we have to take average of this. Average means what? We have to integral, then divide by dt, but we will not do all that thing. Because already we have done average of sine function and average of sine square function. So we will do it in a more easy way. First you write it here. First you tell me, everybody understood till here? Other students? Those who are not saying so much today's class?
Understood, sir.
Other students, as other students, those who are not replying too much. This part you understood or not?
Understood, sir.
Yes, sir.
So applied AC voltage is V naught sin omega t. Munaza is not there today.
I'm there, sir.
Understanding, Munaza?
Yes, sir.
So applied AC voltage. See, AC voltage, matlab Pradyumna also understood. Very good. Question mark means what, ma? Pradyumna, understood or not understood?
Yes,
Understood, no?
sir. Yes, sir.
Because voltage we know, alternating voltage is A sin omega t, but A we don't write. A we write for displacement. This is voltage, so we write V naught. And just now we saw in resistor, current and voltage are in same phase. So this was omega t. No phi was there for resistor. See the derivation. For capacitor, it was current leads. Yeah. So plus 90 was there. In inductor, minus 90 was there. But in LCR circuit, what we saw, there can be some phase difference which we don't know, whose formula we derived, but we don't know the value unless they give us XL, XC, and R, right? So when you don't know, put some symbol. You can't put number, but symbol you have to put. And after finding current and voltage, multiply current and voltage, that is power. Okay. Now, how to find average power? We will not do integration and all. We will use this formula, this symbol, average symbol. Okay. Now, students, these two are not changing with time. Yes or no? Only this function and this function are changing with time. This is peak value. They don't change with time, they're constant. So since these two are constant, average of constant is what? Same only, right? So I can take I naught, V naught outside. What is that? Average of sine omega t into sine omega t plus phi. Okay. Now here what we will do, we will use the formula of sine A plus B. Somebody tell me the formula of sine A plus B.
Sin A cos B plus cos
Sine
A.
A cos B plus cos A sine B. So that formula you apply here. Okay, so fast. Then we'll finish the class. I naught V naught sine omega t. This is sine A cos phi. Sine A cos B plus cos A sine B. Plus cos A sine B, then put like this. Clear everything till here?
Yes, sir.
Sine A plus B, okay? A is your omega t, B is your phi. Now you multiply sine inside.
Sin square
omega t cos phi plus sine omega t cos omega t sine phi. Correct?
Yes.
Now in average you can break, okay? You can give this average here, then average here, because suppose somebody says you find average of 5 plus 5 plus 5 plus 5 divided by 4. Then you can also do this as 5 plus 5, then 5 plus 5 like that. You are understanding? Same thing you will get. Yes or no, students?
Yes, sir.
So this average, like this, you can break it here. If this plus sign, not into sign. Here you cannot do. Here you can do. Plus is there, no? So you can break this. So I naught V naught average of sine square omega t cos phi plus average of sine omega t cos omega t sine phi. Okay, I have broken the average. So the average power will be, this is I naught V naught. Now, in product, cos phi is constant. So you can take it common. It is like this one. Suppose I say A5 plus A6 plus A7 by 4 by 3. I want average. Then what I can do, students? A common I can take. Yes or no? Only you take average of whatever is changing. Artha aita?
Yes, sir.
So cos phi will come outside. And what is left? Average of sine square. And this one is 0. I will show you. Don't worry. Why 0? I will show you. Now tell me quickly what is average of sine square?
Half.
Half.
So this is the formula for average power. Now let me tell you why this 0 came. If you see here, sine phi does not depend on time. So you can
Yes, sir.
remove sine phi outside. Average of sine omega t cos omega t can be written sine 2 omega 2 by 2.
Yes, sir.
And sine function average you know is 0. This is not sine square. This is sine 2 omega t. And you don't care. Sine whatever. 2 omega t, 10 omega t, 100 omega t. Only thing is frequency will be more. If sine omega t looks like this, sine 2 omega t will look like this. Understood, students? But double frequency, no 2 omega t. Matlab.
Yes, sir.
Average will be still 0 because plus will cancel minus. So that's the reason why this average is 0. Okay. This one I wrote sine 2 omega 2 by 2. So what is the final formula for average power? Let us write it in a nice way. I naught V naught cos phi by 2. Can I write like this? No, sir. I naught by root 2 V naught by root 2 cos phi. Can I write like this? Check once.
Yes, sir.
Because root 2 into root 2 is 2. Now,
Yes, sir.
what is I naught by root 2?
IRMS.
IRMS. So average power will be IRMS VRMS. So usually this is the formula for power we write I into V. But in AC, there is I, V, but also cos phi. And that's the reason cos phi is called in this chapter power factor. It is a factor in the formula of power. Okay, next class we will see for this class 5 minutes is still there. Small, this much chotu derivation, 5 minutes derivation. From the diagram, quickly I will show you what is the formula for cos phi. Or you only turn the page and go to that diagram and tell me a formula for cos. Tan I told you opposite by adjacent. So usually in DC circuit, how do we write formula for power? I into V. And in AC, we know I is IRMS, V is VRMS, but there is also cos phi. And that cos phi is called power factor. Let us quickly see the formula of power factor. This was your V naught R, V naught L, V naught C. This 2 after adding, I got this much V naught L minus V naught C. Then I used parallelogram and I added. This was your total voltage and current was here only. And this was your phi. This was O, A, B, C. Check the diagram. Was it given O, A, B, C?
Yes, sir.
Now tell me quickly cos phi from the diagram. Adjacent is OC. Hypotenuse is OB. So I can write OC as V naught R and OB is the resultant voltage V naught. Okay, so you can write from phasor diagram like that. From phasor diagram, power factor cos phi adjacent by hypotenuse. Now Ohm's law you apply. V naught R, I naught into R. V naught, who can tell what I can write V naught?
I naught Z.
Oh, Z, very good. Because Z plays the role of total opposition.
Impedance.
Impedance, super. I naught into Z. Since V naught is the total voltage, so for total voltage, you write total opposition, which is called impedance. So cos phi formula is R by Z. So the 5 times cos phi R by Z. Cos phi, say cos phi also. Cos phi R by Z. 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 Cos phi